303. So we should have gotten, oh, I really need a good pen. Here we go. We multiply to get the top. So 110, and we got 21 on the bottom. Multiply to get the top, -3, add, and we'd get +2, right? Multiply, you guys know the trick for nines, that you can put your sixth finger down? Okay, so this should be mental math. 54, add them together, did you get 15? A negative times a negative is a +24, but you're going deeper in the hole, so you're at -10 when you add them together. We got that okay? Let's see, 7 plus 3 would give me 10, and then 7 times 3 gives me the 21. You get that okay? Right, I'm trying to add to get the bottom. So if I add, what is the next one? 9 plus 4 gets me to 13, and 9 times 4 is 36. Please correct me if you see a mental math error. I would have to what? Subtract 5 to get down to 2. And then 7 times -5 would be -35. Did we get that? Let's see, if I'm at -6, I would have to add 2 to get to -4. And when I multiply, I would be at -12. Let's see, add 5 to get to 17 and multiply, you'd be at 60. Add 11 to get to 21, and 11 squared is 121. Oh no, this is a 10, isn't it? Add 10 to get to 21. So this is the same answer of one of the ones we already did, right? Aren't these two the same? Sorry, went too fast. Did someone catch my mistake though? Did you say, oh, that's not 11? Okay, so let's see. Subtract 3 to get to -9, +18. Did we get that one okay? And then what? 9 plus 7 is 16, and 9 times 7 is that 63? Okay, so we have to know factors and multiplying negatives and positives and that. So yesterday we started, I don't think everybody had time to finish this page on the back. Is this where we were that you were supposed to start on, but then we got distracted by teaching me how to factor? And yeah, the bottom, 13 through 20. Are you guys ready to check those answers, or do you need a few minutes? You need help on it. Okay, so you're in different places, so I'm just going to pretend that we didn't quite get to all of this. They are all trinomials, so that means 3 terms. They all do not have a greatest common factor and have anything other than 1. So, and they all have an A value of 1. 1c squared, 1c squared, 1z squared. So every single answer needs to have 2 parentheses, and you put the variable first in each. So like A times A would go here. On the next one, I don't have room, so I'm going to put it down here. C times C would go here for this one. X times X would go here. This is literally the back page of what we were just on. So when you set up your factors, you just set up 2 terms. Set up 2 terms, put an X in each. Now we have to figure out what's going to go here that multiplies to give me that 2. So that's when we can set up the diamond to help us if we need it, or you could just do it in your head. You put what you're multiplying to get, the 2, here, and you put the middle term, that 3a, the 3 goes here. What are the factors of 2 that add up to 3? And 2 is a prime number, so it has to be 2 times 1 is 2. Those are your factors. A plus 2 and A plus 1 are your factors. You don't have to do the diamond. If you can figure out in your head 2 times 1 is 2, and you can quickly check for yourself that the outer term plus the inner term adds up to 3a. So when you get faster at this, mathematicians and like pre-calculus, you probably shouldn't be writing out of the box to do this problem. If you need the diamond to do this problem. Sure. Okay, so the next one, you're looking for the factors of 5 this time that will add up to 6. What are the factors of 5? Right, 5 times 1. A common mistake. Bathroom or no? Oh, that's right, you're muted. Okay. Okay, good talk. it was a prize from the Smile Camp Sunshine fundraiser. My neighbor won this, so I have to bring it to her. I won this beautiful quilt. Quilts are a lot of work. Oh, I hope I didn't just write pen on it. Anyway, so it was like $25. I bid on it, so I put it on my daughter's bed. And then I got this for my son, so it's funny, we each bid on the like robotic. Huh? I think you. Oh. Oh, that's nice. All right, I want to point out a common mistake with the number 5 and the number 6. A lot of times people quickly in their head think, oh, 2 plus 3 is 5 and 2 times 3 is 6. It must be 2 and 3. Make sure you're always multiplying to get that top number. You can check your answer with a box, right? C squared, and then this would give you 5 times 1 is 5, and your outer plus your inner adds up to 6C total. So could you try the rest of those 15 through 20? Did you say you still needed help on them, or did you figure it out? No. Oh, good. Grayson, has this been familiar at all? Like you kind of see the perfect. This is prime, so it has to be a 13 and a 1 to get to 13. So one of them has to be negative. You have to figure out which one is negative. Matter? Have you seen that thing before? Oh. Well, that's how that yes, we're bringing the final answers to them. So, but hey guys, the diamond puzzle is not the final answer. The diamond puzzle helps you get to the final answer. So it's great on number 15 if you can write, it must be 1 times 7. That needs to get put into the actual parentheses. This is the final answer right here. So make sure the factors, right? This is your final answer. This is your final answer. This is your final answer. Don't stop at the diamond. The diamond is just a tool to get you to the factors. So on number 16, you should get what? R plus 11, R plus 1, right? Take like 1 or 2 more minutes. I'm going to write up the answers. So as you finish them, maybe you can check them on the board. I think most of you did this yesterday. That's probably the next one. Okay, so any questions on that? Are you getting any better? Okay. All right, so let me give you some strategy. So let's say we're having trouble coming up with this one, right? Negative 15, negative 2. Maybe this will help some of you. The ultimate goal is to find the factors of 15. So what I would do over here is I would write down like a factoring tree. What are all the possible factors of 15? 1 times 15, not 2. 3 times 5, and that's it. So if you're trying to find a difference of 2, there's only one of these pairs who are 2 away from each other, 3 and 5. Now it's your job to figure out, does the 3 or the 5 need to be the negative number? The 5 needs to be a bigger negative to add up to the negative 2. So the same thing on number, was it number 19, Kaylee? So like, I'm going to put the 35 over here. It's what, a negative 35 and a positive 2, right? On number 19. So do the same thing. Set up a little factoring tree for yourself with all the factors of 35. and it's not divisible by 6. Now you know that you found all the possible pairs. You're trying to find one of the pairs that has a difference from each other of 2 away. So 1 is 5 and 1 is 7. Now you have to figure out which one is negative. Set up the factoring tree. Don't be ashamed. Just use your calculator to find all the factors. Eventually, if you practice, you're going to start to remember, oh yeah, 5 times 7 is 35. You're going to see a lot of the same numbers. All right, what are the factors of 40? What are the factors of 12? What are the factors of 32? Some of that mental math just takes some practice. Okay, could we go up to the top on this one before lunch? We've got 5 minutes and I want to do the box after lunch. Let's try to do, I'm going to do 1 and 5, and then you're going to try to remember how to do these from yesterday, GCF and difference of squares. So for GCF, you're looking for what is it on number 1 that they both have in common? They both have a factor of 2. You write the 2 outside your parentheses and you divide each term by 2. So what goes in my parentheses? A plus B. So I just factored number 1. You're going to go across and factor 2, 3, and 4. On number 5, difference of squares. They have to have a minus sign and they both have to be a perfect square. You set up 2 terms. And you remember what you do? You're really taking the square root of each of the 2 terms. So you get x times x. And what's the square root of 9? 3 times 3. And what's the pattern that you have to remember? One gets a plus and the other one gets a minus. Right? Difference of squares. So those of you that have been here, take a couple minutes before lunch and try those 12 practice problems. They should be pretty quick problems. You need to know that you've got a quadratic. You have 3 terms, so it's a trinomial this time, and your a value is no longer equal to 1. There's a number sitting in front of your x squared, and you can't factor it out using greatest common factor. Does everybody see we're on page 3-6? So this is the last thing you're looking for. Step 1, always look for a greatest common factor. Step 2, look for difference of squares. Step 3, do your diamond like we just did. Step 4, now this value is like 2x squared or 5x squared. We need to do this method called the box. Some of you might be really good at guessing and checking, and I'll show you how to do it by guessing and checking, because some of you might not need the box, but the box is a strategy to help you get to the final answer every single time. So what you do is you look for the greatest common factor. There is none other than 1. And you recognize that you have 7x squared. And you set up a box. You put the 7x squared in the top, and the 4 goes in the bottom right. Those 29x's somehow are going to get divided up between these other 2 corners. I might put 20x in one and 9x in the other. Or I could put a different amount, like 14 and 15. So how do I split it up to make this factorable? We're actually going to use a form of the diamond. The trick that you have to remember, to get the top number this time, you multiply A times C. 7 times 4 is 28. I'm looking for the factors of 28, and they have to add up to my B value still, which is 29. So what factors should I use? What are the factors of 28 that add up to 29? All right, so 28 and 1, those used to be my answer, right, for the diamond method. Don't write this down. Let's pretend I was confused and I thought that I'm done. How do I know that that is not the correct answer to this quadratic? When I check it, what's the first term that I would check? X times x should be 7x squared. So this is not the correct factoring. I'm just going to put this 28 and this 1 into these boxes now. That's how I'm going to split up this 29x, 28x and 1x. And it doesn't matter which box you put them in. because 28 plus 1 is still 29 x's. Now you're going to do reverse multiplication. You know how when you multiply on the outside of the box, you get the inside of the box? We have the inside, and we need to figure out what the outside is. What are the only factors of 7 that I could possibly use? 7 and 1. Don't write this yet. Where do you think I should put the 7? Do you think it should be 7x times x in that order? Or do you think it should be 7x times x in that order? So, the other way. Why do I know that it's the other way? And I have to put the 7x in this row because when I look across, how am I going to make 28 x's? 7 times 4. And then how am I going to only make 1x? X times 1. So there's a little bit of problem solving about where to put the terms. These are your final answers right here. 7x plus 1 times x plus 4. I've actually proven that I have the correct answer because this is showing that when I multiply it out, I get back to the original quadratic. Does this method seem familiar to you? Okay, so I just want to show you, in case you don't really like the box method, but you're a pretty good guess and checker, if you have a prime number like 7, you would know that this has to be 7x times x at 7x squared. What are the possible factors of 4? 4 times 1, 1 times 4, or 2 times 2. You could really check and see which of those 3 combination works if you can't remember how to do the box. Like, oh, if I put a 4 here and a 1 here, does this get me to the right answer? It doesn't, because what is 7x plus 4x? That's only 11 x's. So what if I try this combination, 7x plus 1, x plus 4? Now I get 28x plus 1x is 29 x's. So you can really guess and check when you're factoring. You don't have to do the box method. All right, number 2. I check for a greatest common factor. I recognize the a value is a 2, so I have to do the box method. 2x squared goes here, and negative 9 goes in the bottom. Now I have to figure out how to strategically split up these negative 3x's between these 2 boxes. So I set up a diamond, and I do 2 times negative 9, negative 18, and I put my negative 3 in the bottom of the diamond. So what are the factors that I want of negative 18? What times what is negative 18 and adds up to negative 3? We're on 3-6. Yep, 6 times 3 is 18. Which one needs to be negative? The 6 or the 3? I'm trying to add up to negative 3. All right, so negative 6x, positive 3x. It doesn't matter which x you put them in, you'll get the right answer. All right, the only possible factors of 2x squared are 2. So 2x times x. Do I want to put it in that order? Or do I want to put it 2x times x? So you think about, what are you going to do next? If I leave this here, how am I going to multiply to get 3 x's? That looks messy. So switch back to what you started with. That's a little bit better because I can multiply to get this and I can multiply to get this. You just have to use a pencil and you just have to put it in one of the spots and see if you can do the problem or not. Does it make sense how to tell which side of the box it has to go on? 2x times x is going to work better for me than vice versa. So I would need a 3 over here, right? X times 3 is 3x. What would I need up here? Negative 3. And you can see if you did it right because these 2 have to multiply to give you this. And that's how you can check that you did it right. So your final answer, 2x plus 3, x minus 3. These guys go together and these guys go together. And it does not matter the order that you write. If you want to write x minus 3 first and 2x plus 3 second, that's the same thing. Which one? Where did I get this from? Over here? Inside the box? Well, why does that matter? Oh, you missed the first question. Okay, we're going to do some practice. So I can give you the resource at the end. Or do you want to take a picture of it really quick? I would come back to this. I think we're going to do some practice, so then this will make more sense. So the next page has common mistakes to look out for. So before we practice, what are some things that we should look out for? First of all, you always need to put your equation in standard form. Remember in Teach Me How to Factor? I forget what he says. Like, look at your quadratic, set them up high to low, right? So high to low, this is not in standard form. How can I rewrite this in standard form first? X squared plus 5x plus 6 equals 0. Now I'm ready to factor it. So let's go through our factoring bucket of tricks. 1, is there a greatest common factor to take out? Greatest common factor? No, but at least I checked for it. Number 2, is this a difference of squares problem? Number 1, is there a subtraction sign? Is there only 2 terms, and are they perfect squares? No. All right, so I'm going through this bucket in my head. Is it a trinomial? Yes. Does A equal 1? Yes. 1x squared. So I'm using strategy number 3. I don't have to do the box method, right? That's when it's trinomial like today. So I'm using the diamond method. Set up 2 terms, put an x in each. Now you're going to do the old diamond because the A value here is 1. So you just do 1 times 6 is 6. And we're looking for the factors of 6 that add up to 5. Not 1 and 6 at all. Try a different set of factors. Give me it. But 5 times 1 is not 6. 3 times 2 is 6. And doesn't 3 plus 2 add up to 5? These are solutions for inside our factors, right? So this factors into x plus 3 times x plus 2, and it says equals 0. How do I find my final solutions for my x intercepts? Set them each equal to 0. So x equals what or what? Negative 3 and negative 2 or negative 2. All right. The second thing to always look out for, I put it over here, but you should always check for greatest common factor first. Which problem is the hardest? Probably doing the box method has the most steps. If you could eliminate doing the box method, wouldn't you want to? Do you see what you can divide out in this problem? You can divide out a 2 before you even start. So if you want to, you can factor out 2, and what would you have left when you divide each of those terms in half? X squared, and then what? Minus 3x minus 4. Now I'm looking at this right here, and that is another trinomial like this, when A is now equal to just 1. I'm kind of ignoring this 2. I'm covering it up until the end. Now I'm going to factor this guy using my diamond method. 2, set up 2 terms, put an x in each. This 2 is just the greatest common factor. It's just following the problem. I'm worried about factoring this underlined part right here. So how do I set up my diamond? A negative 4 and a negative 3. I'm covering up this 2. It's the greatest common factor. It's not involved in this trinomial. What are my factors of negative 4 that I should use? Is it going to be a 4 and a 1 or a 2 times a 2, do you think? a 4 and a 1, I need to figure out which one I should make negative. The 4. That way it's bigger and I get a -3. X minus 4, x plus 1. These are my inside my factors. Now I need to write my final answer. Does the 2 give me an answer? It would if there was an x there. Because it's number 2, it's always number 2. It can never be 0. So x can be what or x can be what? 4 or -1 would be my two x-intercepts. Okay, so we're always going to put our equation in standard form. We're always going to look for a greatest common factor. That makes our job easier. All right, the other thing we have to look out for, you can only solve a quadratic if it's equal to 0. So the zero product property, it only works if you are equal to 0. How can I move this -4 to the other side? The opposite of that would be add 4. So I have x squared plus 11x plus 24 equals 0. See if you can do your diamond method to solve that problem. I already set up my 2 terms. I've already put my x in each. You set up the diamond and after that. That's from yesterday, not today. None of these are in the box. I'd like to get one more box in though before we leave. So the factors of 24 that I want are what? Yep, so if you stop, what I said was 1 times 24, 2 times 12, 3 times 8, 4 times 6, and I can't do 5. Those are the only 4 combinations, right? And you need your combination to add up to 11. So if you try to stack them in order, maybe you would have figured out it was 3 and 8. So x plus 3, x plus 8. What are my two x-intercepts then? -3 or -8. Okay, so always make sure your equation is equal to 0. And then the last thing, always be on the lookout for a prime quadratic. Just note that prime does not necessarily mean no solution. We're going to learn another strategy, but this is an equation that's prime, right? I can't factor it because it's plus sign. And then this is going to be a prime, and we're going to see that it does have solutions. So minus sign, and we will learn how to take square roots. If you want to. I mean, this is just your resource pages. So if you're flipping through it and you're like, oh, I can't factor this. I wonder if this has solutions or not. We're going to learn when it has solutions or not. But those are like the things to look out for. Make sure you do the greatest common factor and set it equal to 0. All right, I want to do a couple more blocks and then you're on your way till we practice again on Friday. But can I move that now or almost? I think this is, we're going to 304. That's on my page. Yep, 304. You can flip to 304 while you're flipping. I'll leave that up there for a second. Let's just do a couple more together and maybe try one on your own. What time are we here till 54? So we have like maybe 10 more minutes. Maybe I'll do 2 and you can do 1 of them. These are all kind of box method ones. All right, number 1. Does number 1 have a greatest common factor other than 1? Okay, does it have an a value that is bigger than 1? Yes, it is 10x squared. So I'm going to set up my box, putting the 10x squared up here and the 3 down here. And now I have to figure out using the diamond how to strategically split up that 11x into those 2 boxes. So you do a times c. 10 times 3 is 30. And the middle term, the b term, is 11. What are the factors of 30 that add up to 11? 10 and 3 is a factor of 30. Yeah, it has to add up to 11. So what factors should I use? Factors of 30? 5 times 6 is 30. So I put a 5x in this box and a 6x in this box, and now I try to do the outside to make it work. I'm going to give you a minute. It doesn't matter what boxes you put them in, but now you should be mindful of what you're going to put outside, because you have to multiply to get what's inside. And 10 has a couple different possibilities, a 10 and a 1, or a 2 and a 5. So you're going to have to do a little bit of problem solving. What should I put on the outside of those boxes? You try it first. Put something down and see if you can get it to work. And if it doesn't work, erase it and try something else. Yep. If it's negative side, then we can't. And see, these squares though should have come out as positive 64. When you put the negative 8 in parentheses, this is 64 minus 60. So you should come out to equal to 4. Put the negative 8 in parentheses. Thanks. Good for you. I think because I see this 5 over here, I'm going to guess that this is a 5x times a 2x, and then I'm going to see if it works. I'm not going to try 10 because it would be hard to get a 5x or a 6x if one of these guys was a 10x. So it must be a 5x and a 2x. See if you can fill in the end of each of those binomials. Now that you know where those two pieces of the puzzle go, can you figure out the second piece of the puzzle? Factoring is a lot of mental math and puzzles. And the more you do it, the better you're going to get at it. You're going to see the factors. Your brain's going to start thinking about factors. So you're going to put a +1 here and a what? 3 here. 1 times 3 is 3. So 2x plus 1 times 5x plus 3. On example 2, what am I looking for first? Is there a greatest common factor? You're right, that would be good. What can I pull out? A 3? Just a 3, I think. I can't pull out the x squared. But I'm gonna draw out that 3 so that I have an easier time factoring my quadratic. What would I have left when I divide by 3? Just x squared minus x and minus 2. Now I don't need the box anymore. So don't just be tunnel visioned. Oh, I have to do the box. Greatest common factor might make it so you don't even have to do the box at all. So you set up your two terms, you put your x in each, and you're going to do the diamond to figure out what goes in those two factors. You're going to put the -2 up top and the -1 on the bottom. So we're looking for, we know it has to be 2 times 1 because 2 is prime. Which one should be negative? This -2 and this -1. I'm ignoring this 3. The 3 is just along for the ride. Huh? Like 20 is 2 root 5. I want the 2 to be negative, don't I? -2 plus 1 is -1. X minus 2, x plus 1. Man, all of these have a greatest common factor first. Let me just see. All right, I'm going to have you do one on your own. So, but not 3 or 4. Can I turn the page? See if you can do one on your own as the last problem. See if you can try example 5, because this does not have a greatest common factor. You're just going to start by setting up your box. So I'll just remind you that when you're setting up your box, 2x squared goes here, -4 goes here. And now you're going to set up your a times c goes on top and b goes on the bottom. See if you can do it. Yeah, let me just, did everybody get that if they wanted to write that part down? Right, you should have put -8 here, -7, and -8 times 1, right? So this is -8x, 1x. Maybe yours are in the opposite order, but we should end up with the same factors at the end if you got that much. Oh, well, yeah, I mean, it's a week. So technically, the next 2 assignments aren't due till tomorrow. So I would say definitely if you want any credit for 2-7, that needs to be in tomorrow. Yeah, no, 3-1 should also be in tomorrow. And then 3-2, 3-3 if you need to get them to me Monday. That literally is due for the class today, tomorrow. Some of them didn't turn in 3-2 yet. Sorry, 3-2. 3-2 was due today, 3-3 is due tomorrow. So I would say by Monday, have 3-2 and 3-3 all done. Okay, so let's see. Just check our answer. We should have probably put what? 2x here at that -8. So we need a -4 and a 1. X minus 4 and 2x plus 1 equals 0. So my x-intercepts, I would get a positive 4 here or a -1/2 from the second parenthesis. Did people, some of you get there? That's like the hardest factoring problem that you would get on the test. Recognizing the box method, being able to set it up and solve kind of a harder factor for -1/2. To me, that's the hardest factoring problem that we'll do. So if you can do the box and then everything that came before it, you're in pretty good shape on your bucket of 4 factoring methods, which we're going to practice tomorrow. Practice, practice, practice on factoring. So I hope it makes it factoring easier for you because this is your second time around